All right, today we're going to pull back the curtain on one of the most basic, most fundamental ideas in all of programming, the string. Now, it might sound a little technical, but trust me, by the end of this, you'll see it's actually super simple and incredibly powerful.
I mean, really think about it. Every single piece of text you see on a screen, the name of a character in a video game, a message from a friend, even these words right here, a computer has to make sense of it all. And computers, well, they really only think in numbers. So how does that even work? That, my friends, is exactly where strings come into the picture.
And that's it. Seriously, there is no need to make it more complicated than that. Anytime you, as a programmer, need to store and work with text, whether it's a name, an address, a whole sentence, you're going to use a string. It's the bedrock for handling text.
And don't get tricked into thinking strings are only for letters from the alphabet. Oh no, their real strength is how flexible they are. A string can hold a super complex password, with letters, numbers, and symbols. It can be a street address. It can even be totally empty, which, you guessed it, we call an empty string. At the end of the day, it's just a sequence of characters.
Okay, if you only remember one single thing from our little chat today, please make it this. For a computer, a bunch of letters is just, it's just noise. It's meaningless. You have to explicitly tell the computer, hey, this stuff right here, I want you to treat it as one single piece of text. And the way we do that is by wrapping it in quotes. And here is the perfect show-don't-tell example. On the left, without any quotes, the computer just gets totally confused. It thinks gray fox must be some secret command or another variable it's supposed to know about. It doesn't, so it just throws up its hands and gives you an error. But look at the right. The quotes make it crystal clear. This isn't a command, this is just the text, gray fox. And it works. That's the magic of quotes. Okay, so we've got a handle on what strings are and how to create them. Now we get to the really fun part, actually playing with them and changing them. We're going to start with the two most common things you'll ever do, sticking strings together and pulling them apart.
Concatenation. Yeah, it's a big fancy word, but the idea behind it is so simple. It's just the official term for joining strings. And I love this little factoid. It comes from Latin, and it literally means to chain together, which is a perfect description of what we're doing.
So let's see this in action. Imagine you have two puzzle pieces. The first piece is the string hello. Our second piece is a variable that we've called name, and it's holding the string Winston. To connect them, we just use a simple plus sign. And what do we get? A brand new single string that says hello Winston. See? Simple.
So what about the opposite? What if you want to do the reverse? You don't want to join things, you want to grab just one little piece from a much bigger string. Well, that little piece is called a substring. It's kind of like taking a slice out of a pizza. Here's a great example. We tell the computer, okay, look at this string, Harry Potter. I want you to start at position 0, and then give me the next 5 characters. And what does it spit back? Harry. But wait a minute, position 0? What's that about? Well, this right here brings us to a massively important idea in programming.
This leads us to one of those things that trips up almost every single person when they're first starting to code. It's this tiny little difference in how computers count versus how we count. But understanding it is absolutely critical.
This is a golden rule. You just have to burn it into your brain. When we count things in the real world, we start with 1. Computers, on the other hand, almost always start with 0. The first thing in any list, the first character in any string, it's always at position 0.
Let's just look at this with the name Harry. To us, H is the first letter, right? But to a computer, H is at position, or as we call it, index 0. The A is at index 1, the R is at index 2, and it just keeps going. Getting comfortable with this zero-based counting is going to make your life so much easier.
So let's just hammer this home one more time so it really sticks. When you're thinking about where a character is in a string, the starting line, it's always 0.
So beyond just sticking strings together or slicing them up, most programming languages give you a whole toolbox full of other useful things you can do to them. Think of it like a Swiss Army knife, but just for text.
So what's in this toolbox? Well, here are a few of the greatest hits. You can ask the program to find the index of a specific character for you. You can change the entire string to be all uppercase or all lowercase with one command. Or you can just ask it, hey, how long is this string? And it'll tell you the total number of characters. Now, this is where it gets really cool and really efficient. You don't have to use these tools one at a time, step by step. You can actually chain them together, performing one operation right after another in a single clean line of code. Let me show you what I mean. Okay, let's start with this simple address.
Our goal here is to pull out just the street name, Baltimore, and we want to make sure that it's in all capital letters.
So the first move in our chain is to hit it with a 2 uppercase operation. And bam, just like that, the entire string is now capitalized. But we're not done.
Right on the heels of making it uppercase, we immediately tell it to perform our next operation, slice out a substring. We give it the starting index and the length we want, and boom, it carves out our final result, Baltimore. 2 operations done in one smooth, seamless command. That's powerful.
Now you might be sitting there thinking, okay, is this just a JavaScript thing or Python thing? And the answer to that is a huge, resounding no. The idea of a string is pretty much universal in the programming world.
Just look at this. Whether you're coding in JavaScript, Python, or Java, the core concept is exactly the same. You've got a variable, an equal sign, and some text wrapped up in quotes. Sure, the little details of the syntax might change a tiny bit, but the fundamental idea of what a string is and what it does, that stays the same everywhere. So, let's just do a quick recap of the most important stuff. Number 1, strings are just text inside of quotes. Simple. Number 2, computers start counting from 0, not 1. That's a big one. Number 3, you've got a whole toolbox of operations to join, split, and change your strings. And finally, this isn't some niche topic. It's a core concept you'll find in almost every programming language out there.
So, we've cracked the code on how computers understand and work with text. But that's just one type of information. What about all the other stuff? What about numbers? Or what about simple true or false values? What other kinds of data do you think a program needs to be able to understand to do all the amazing things it does? That's the next step on this journey. Thanks for diving in with me.